Hello, everyone. Welcome back to another online seminar, which is held by ECONIT, German-Indonesian Chamber of Industry and Commerce, and GIZ, with our theme today, Beyond Green Hydrogen, Exploring Derivatives and Their Fields of Applications and Markets. My name is Rico Siaan, and I'll be your moderator for today's event. I'm very glad to see you all in this seminar. So before we start, I would like to inform you several information. The first is that we genuinely invite you to participate in this seminar through questions and comments. You can post your questions and comments in the Q&A tab in your Microsoft Teams. We will discuss the questions or comments that came in right after each session finished. So, ladies and gentlemen, a bit introduction about our webinar today. From our last talks, we have heard lots of German innovators and developers. And as of today, we are very lucky to see significant development about hydrogen happening in Indonesia. One of them is the inauguration of Indonesia's first green hydrogen by PLN. And we are very lucky to have a speaker later from PLN. And also from my record that Indonesian government is doing the fast tracking for regulatory framework for hydrogen use. So I believe we are about to see very interesting times for hydrogen development in Indonesia. So, ladies and gentlemen, today we will look beyond green hydrogen, not only hydrogen, but also its derivatives such as green ammonia, their applications, and of course the markets. We have interesting lineups of speakers that will share to us their perspectives and perhaps their business plans. And without further ado, I invite the first speaker, Mr. Tim Nies, Project Manager, H2UP Program GIZ Thailand, to deliver his opening remarks. Sir Tim, this virtual stage is yours.
Thank you very much. Ladies and gentlemen, good afternoon, and welcome to the second H2UP online workshop on green hydrogen in Indonesia, organized in collaboration, as it has been said, between GIZ and the German-Indonesian Chamber of Commerce and Industry. My name is Tim Nies, and I serve as the project manager of the International Hydrogen Ramp-Up, in short, H2UP, in Southeast Asia. The program is commissioned by the German Federal Ministry for Economic Affairs and Climate Action to support the ramp-up of green hydrogen markets. In our first workshop, organized in September on how to move green hydrogen forward in Indonesia, we explored together with representatives from the Ministry of Energy and Mineral Resources, the Indonesia Association Fuel Cell and Hydrogen Energy, as well as Indonesia and German companies, current ambitions, strategies, and policy around green hydrogen development. Today, we continue this path with a series of new perspectives from public and private sector representatives, not only on green hydrogen development, but with a focus on the world of hydrogen derivatives, markets, and business opportunities. Green hydrogen and its derivatives are key enablers for our collective efforts to achieve a sustainable and decarbonized future. Therefore, H2UP provides platforms and support with knowledge and instruments to foster the development of such projects necessary in order to create value chains, markets, and then also international markets for hydrogen and derivatives. Moreover, H2UP is evidence of the German government's commitment to promote international cooperation and innovation to accelerate the transition to a green economy. H2UP operates through three core fields of activities. We support expert exchange. We create platforms and networks for hydrogen stakeholders in Southeast Asia to come together, exchange ideas, and learn from each other's experiences. Collaboration is the cornerstone of progress in the hydrogen sector, and we, as H2UP, are dedicated to facilitating it. We support also public-private partnerships by actively engaging with companies to jointly develop hydrogen project ideas and concepts. For example, we collaborate with companies to prepare pre-feasibility studies and by offering trainings. This partnership-driven approach ensures that promising initiatives see the light of day, driving the adaptation of green hydrogen technologies forward. We also support capacity development. We provide and share essential knowledge resources around green hydrogen and PTX through studies, conferences, and trainings. Our aim is to reduce the risk associated with engaging in hydrogen projects and to empower business and individuals with the insights needed to navigate the complexities of this evolving landscape. Most importantly, in H2UP, we are excited to support your green hydrogen initiatives as companies, may it be related to bringing your solutions to new markets, finding international business partners, or providing insights and know-how to your projects. So please feel free and encouraged today to make the best of the workshop by actively engaging in the discussions, by asking questions, and by sharing your insights. Thank you for your attention, and I look very much forward to the fruitful discussions and exchange and collaborations that will hopefully emerge from this workshop. Thank you.
Thank you so much, Sir Tim. It was a pleasure to see you again in this seminar. Right, now we continue to our second speaker in this session. We will hear a keynote speech that will be delivered from the Ministry of Industry. The presentation will be brought to us regarding the potential of green hydrogen as green source of energy for Indonesia's industries. Welcome Mr. Beni Adi Purwanto, Head of the Sub-Directorate of Machinery Industry, Electrical Equipment and Medical Devices from the Ministry of Industry, Republic of Indonesia. Without further ado, I give this virtual stage to Pak Beni. Silakan Pak Beni.
Okay, thank you, Mr. Ricordias. First of all, I would say to deliver our apologize because actually right now is will be delivered by Dirjen Taufik Bawazir, Director General of Metal, Machinery, Electric, and also Transportation of Ministry of Industry. But actually right now there is there is another agenda in with the same time. Right now there is a high-level meeting with our Minister of Industry. But today, in this afternoon, I will deliver his keynote speech according to the potential of green hydrogen as green source of energy for Indonesia industry. First of all, I will say to the Honorable of Mr. Timnis, and then Mr. John Donfield, and Pak Ricordias for having us today in this very interesting discussion about the green hydrogen. Okay, next. Lately, we see that President Joko Widodo already said the government is currently working on the several major transformation, including structural, facilitating investment, conducting downstream, and then transformation into digital economy and also renewable economy transformation. The sustainable equity and sufficient electrical energy is one of the key to the success of this transformation. On the G20 presidency, also has clearly stated that Indonesia focusing on the inclusive global health. The second is digital economic transportation, and the third one, the last one, is a transition to the sustainable energy. But right now, in the midst of the slowing global economy and the falling price of leading export commodities, Indonesia national economy in third quarter 2023 was able to grow 4.95% and has continued to maintain positive values in the recent year. This is an investment opportunity, especially in the energy sector, with the expansion of the industrial sector and the future industrialization plans, and a more competitive energy supply is a key to achieving the golden Indonesia in 2045. Next slide. Okay, on this slide. Domestic energy supply in the 2030 is estimated only be able to meet 75% of national energy demand. This is the potential shortage supply in the future will endanger the national energy security, which will directly affect to the availability of energy as a raw material and auxiliary material into the industrial sector. The effect in some citizens to the world do not have access to the affordable, reliable, sustainable, and modern energy. This is one of the challenges in the energy transition. The other challenge on the energy transition process require enormous fund and research and technology support to produce the new technology. But in the case of fund, there is an opportunity to utilize the funding from Just Energy Transition Partnership or JETP. The partnership aims to accelerate the just and gradual energy transition process in Indonesia electricity sector. Through JETP, Indonesia is committed to reducing its peak greenhouse gas emission to 290 metric tons of the carbon dioxide by 2030, accelerating the share of new and renewable energy mix out in overall energy mix to 35% by 2030, and achieving net zero emission by 2050. To support Indonesia achieving this target, IPG member has pledged around 20 billion US in funding from both the public and private sector to finance Indonesia energy transition project. We hope the JETP funding could be utilized as soon as possible to funding the energy transition program in Indonesia. Next. In this slide, we see that the Ministry of Industry already make some projection in the one industrial subsector in 2035. We can see that there is an amount of energy that we will have to comply or we have to fulfill in the future. The renewable energy, especially right now, is a hydrogen technology. We see it is a new energy source that could be an option to replace fossil and coal energy in the future, because the amount of energy that we needed in the industrial sector, if we see the renewable energy power plant right now, like maybe solar power plant and others resources, I think it will be very need a very large of area, especially in the solar power plant. But the hydrogen has very potential to support the energy fulfillment in the future. The hydrogen fuel is a zero emission fuel that used as a fuel for generating electricity. There are some benefits like zero emission, strong reliability, and then the lower operation and very scalable. I think this is one of the potential of the hydrogen as renewable energy in the future. Next. In the automotive sector, the government of Indonesia through Ministry of Industry already set up a roadmap for development of Indonesia automotive industry. Especially in the fuel cell for the vehicle technology, the government already set up by 2030 in the field of transportation, the internal combustion engine will also reach the state of using hydrogen. In addition to developing hydrogen fuel cell battery for all car vehicle application, we must start from now on for this potential. All relevant stakeholders prepare their capability, both technological and also human resource. And then next. This is maybe one of the utilization of the hydrogen in industry in Indonesia. We have some of the project plan by using JETP funding. One of them is how to utilize hydrogen in the industry. In this case, the industry is using steam from the hydrogen boiler. The hydrogen will be supplied by a hydrogen generator, and the hydrogen generator will be powered by PV generation that constructed in the rooftop of the factory. From the calculation, if we have 6.3 megawatt of the solar PV, it will be produced around 970 meter cubic of per hour of the hydrogen, and it will be generate steam to the production process. And the average, or maybe the estimated CO2 reduction will be around 614 ton per year. This is a very potential develop of the hydrogen in industry, but I think it still need funding to execute the process. And one of the producer of the hydrogen boiler is Miura. They are ready to develop the hydrogen boiler in Indonesia. And then next. This is about the development of the hydrogen by using natural gas or from renewable energy such as wind power or solar PV power. In this case, it is related with the strategy of Indonesia to phase out or reduce the utilization of the coal in the power plant by 2030. The utilization of natural gas or renewable energy power plant in hydrogen and ammonia generation will be the best solution to enhance the electricity supply in the future. Next. Maybe the next about the utilization of the development of green ammonia and or green hydrogen will be delivered from PLN, but I think we can see from this slide that PLN already start the trial of the development by using the ammonia in one of the coal power plant in Gresik. And the technology is provided by one of the industry in Indonesia, PT AHK Power Service Indonesia, ex PT Cilegon Fabrikator. I think this is will become one of the solution to utilize the infrastructure of energy in Indonesia, because by using the combination between hydrogen, renewable energy, and ammonia, it will provide the energy by using the infrastructure that used in the steam power plant before. In this case, I think in the next development of the hydrogen, it will be bright in the future, especially in the steam power plant like in Gresik. And then with the increase of the portion of renewable energy in the RUPTL 2021 until 2030, and the transition policy toward the net zero emission 2060, this show a picture of the need of market potential for renewable energy component industry, which is huge. This large market must be utilized as much as possible by domestic industry. Where is it? I'm sorry, if there any check. Okay. There is a problem with my voice.
I can hear you, Pak. I
okay.
still can hear you. Yeah.
Oh, because there is someone chat that he can hear the voice. We see that the large market possible by the hydrogen, it can be utilized by the industry, and then we see that the industry is play the significant role in the development of the energy sector. The industry will generate the demand. I think right now in the electricity sector, industry sector is the one of the most sector that utilize the biggest number of electricity. But in the other side, the industrial sector is also provide machinery that will utilize to generate energy itself. So I think this condition will be good in Indonesia to develop the sovereignty of the energy. And then for the last, to sum up, we express our appreciation and gratitude to all relevant stakeholders for organizing the Beyond Energy Hydrogen Online Seminar, which at this event is a form of commitment from all of the parties in the context of success of Indonesia Net Zero Emission 2060 program. Thank you very much.
Thank you, Pak Beni. I think Pak Beni can stay with us, ya Pak, for the next maybe 5 to 10 minutes, ya Pak, for questions and answer. Okay. Now I see several questions already submitted in the tab. Okay. Let me see. Okay, there is one question. The first question is for Pak Beni, from Pak Cahyo. Pak Beni, can you elaborate, Pak, more about the industrial hydrogen project that you mentioned in your presentation? Where is the location and is it still in feasibility study? Please, Pak Beni.
Okay, thank you, Pak Rekordias. Okay, Mr. Cahyo Budiman. The project about the utilization of the hydrogen in industry that I have already mentioned before, right now is still in the feasibility study phase. They are right now is still looking for the funding to execute the project. I think they want to utilize the JETP program in this project by utilization of the JETP program. They will make a study in how the combination of the PV solar rooftop to power the hydrogen generator that will be used in the hydrogen boiler. But I think it's still in the phase of the feasibility study, and they are looking for the funding from this project. This project is carried out by NEDO, but maybe they will announce about the location and the project itself. I think if they are ready to execute their program. Thank you, Pak Rekordias.
Okay. Thank you. I think I have one question for Sir Tim. Sir Tim Nis, question that came to me directly. Sir Tim, there is a question of what kind of scale of hydrogen project can GIZ help or give assistance in Indonesia? Sir Tim, please.
So we are, as I mentioned, I'm happy to support the project development with companies in Indonesia. And the scale of projects we're looking for is between a project volume of 200,000 euros and 4 million euros. Maybe you can translate that into local currency. These projects, however, have a special condition which is important to consider. As we as GIZ, a representative of the German federal government, use taxpayers' money, we are required to use these funds for projects that are beneficial for the overall industry. And this means whatever we do together with companies has to be made available for other market participants. So this means what we generally do as H2UP is to support with pre-feasibility studies, support with trainings, support with policy, regulatory consulting, support with questions on missing standard certification, just to name a few topics. And these are the topics we would like to work on also in Indonesia. But again, companies have to be aware that we are looking for projects that are beneficial for the overall market development. But if there are certain project ideas, I would be happy and my team would be happy to also discuss that in detail to see whether it fits into the program.
Right. Thank you. Thank you, Sir Tim. And okay, I think we are getting more tractions from the audience. But okay, I'm gonna take a question that is relevant that can be answered by Pak Beni or Sir Tim. Question from Thomas Wagner. maybe this is addressed for Pak Beni, Pak. Maybe you can answer as the views from the Ministry of Industry. The question is like this, Pak. Are you aware of the biogas potential to produce green methanol or green ammonia? Will the Ministry of Industry support this kind of possibility? Silakan Pak Beni.
Okay, thank you, Mr. Kurdes. According to the question about biogas potential right now, I think Indonesia really huge potential, especially in the palm oil mill. They are producing biogas and also biomass. Maybe some of them already utilize their pome to produce biogas, and maybe they already utilize as one of their power plant. But I think right now the Ministry of Industry doesn't have any policy that directly support the development of the biogas or biomass itself, but in the discussion with another parties like Ministry of Energy and Natural Resource and also with the PLN, they already put the biogas and also biomass as one of the as a source of the renewable energy in the future. And I think in the industry, our concern is how to the local manufacturer can also join and also participate in the development of the biogas and biomass potential. Thank you.
Right. Thank you very much, Pak Beni, for the response. Okay. Any more questions from the floor? Okay. Okay. One last question, maybe for Pak Beni. Maybe also because our time constraint. The last question is from Pak Jakob. The question is: has our government defined competent standard in hydrogen from generation to utilization? Are there any trainings, Pak, or certification provided? Silakan, Pak Beni.
Yeah, I think the discussion about the utilization of hydrogen is still very new in Indonesia, especially utilization in our energy and also in industrial sector. Right now, we are still looking for the development of the energy itself, about maybe the safety and other aspect. So right now, we still don't have the standard on how to produce, on how to transport, and how to utilize the energy or also ammonia. But I think it's all of them. I think it's already in the discussion right now, and we hope that in the development of the technology itself, the standard will come up soon.
Okay. Right. Exactly on time, ladies and gentlemen. With that, I close this session, and on behalf of the organizer, I would like to say thank you very much to Sir Timnis from GIZ Thailand and Pak Beni Adi from the Ministry of Industry, Republic of Indonesia. We wish you very good luck in your future endeavors. Thank you, gentlemen.
Okay. Thank you, Pak Gordias.
Right, now we continue to our next session, where we're gonna talk about standardization of green hydrogen and its derivatives for the international market. Our first speaker is Mr. Stefan Duch, founder and managing director of HEE Technologies. Mr. Stefan Duch, this virtual stage is yours, please.
Okay, yeah, thank you very much for your invitation. Good afternoon. Yeah, so as you already mentioned, I'm the co-founder and managing director of HEE. And shall I share the presentation from here or you share it?
From your side is okay.
Okay, just give me a moment. Can you see the presentation?
Can you switch the display, because I see the admin.
Okay. Is it better now, or it's still wrong?
Yes, that one. Okay, perfect.
Yeah, I think now it's better. So this is always a bit. Okay, yeah, so thanks for the invitation. So the topic today is exploring business potential in international markets for green hydrogen and its derivatives. Maybe as an introduction, this year I traveled a lot. So I went to conferences and meetings in Saudi Arabia a couple of times, in Egypt, in Germany, China, and also to some extent in Indonesia. So I start with quite a broad introduction and will also give a little bit my own impression. But maybe first, some introduction about HEE. So HEE stands for Hydrogen Energy Era, and we are convinced the transition cannot work without hydrogen. We currently have two business activities. I just give a very short introduction about the company, just 3 minutes. So we help governments to plan and switch whole areas to hydrogen. And we also develop our own station fuel cell systems. Right now, we have 2 locations, one in Germany and one in China. And we also have, let's say, through our Chinese joint venture, a very extensive and strong partner network. So what we do for the, let's say, the first type of work we do is we go to governments, decision makers, like on a provincial level or on a city level, and we consult the whole chain. So based on the local condition, we analyze how to produce hydrogen. There are the different ways. Everyone is talking about electrolyzers, but there are also other ways to produce hydrogen, like from biomass or waste, or also byproduct hydrogen from chemical industry. Then you have the hydrogen, how to distribute. We strongly push hydrogen gas grids, and then there are different hydrogen applications. So this is, let's say, one thing we do. And the reason why the local governments like this idea is they want to generate a local industry. I show this page because I think it is also important for Indonesia. It's not only about exporting energy, you also want to develop a new strong industry. I think that should be the target. We also believe that it is very important to use station fuel cell systems for power, heat, and cooling in order to make the whole energy system resilient. Later, I will say a little bit more about that. And it links also with the introduction from Beni Adi. I hope I pronounced that correctly, because he also has a focus on power production. So this is where I was very happy to see that. So now let's go a little bit about the topic. So the international business opportunities. And I start with some big figures from the IRENA report. So what we can see is that the size of international trade for energy will be quite similar. So if we compare 2020 to 2050, so one is 1.5 trillion, the other one is 1.6 trillion. I mean, the first conclusion is the size is very similar. But then let's say the components change a lot. So obviously oil, coal, and gas are reduced greatly, and they will be replaced by hydrogen and its derivatives. So hydrogen, methanol, ammonia, they will all be based on hydrogen, very likely. And I was very surprised to see there's such a big portion of bioenergy. Actually, on an international level, I'm not aware of such a big discussion similar to hydrogen. I was a bit surprised to see this big value for bioenergy. But anyway, right now, today, we discuss about this portion. And this will represent 22% of the, let's say, end energy usage. So it's a very big portion of the energy usage in 2050. And here we also see some trade routes. I think it's important to understand to some extent, it will be like a blank sheet. So in the past, the energy exporting countries were based mainly on oil or coal. So this is, let's say, just a geographical condition. You either have it or you don't have it. But now it's totally different. Now it's mainly solar power or wind power. So some regions become relevant who previously were not relevant at all. For example, Latin America will play a big role. From the European perspective, North Africa and also the GCC countries will play a big role. And let's say for Asia, Australia, and hopefully also Indonesia will play a big role to export energy. So just to highlight this is like a new game. And you also see, so if we look at the international agreements, I think this is based on the figures from 2021. This topic is handled on the government level. So I want to stress to say there are many international cross-country agreements in place now, and they are negotiated. And I think there's a lot of activity, and I see a lot of activity. And I just want to stress some energy exporting countries are totally new, and they're only new because of the change of the conditions. For example, Denmark previously would never export energy. Also some Latin American countries. So this is just for a general introduction. And I think it will depend a lot on government agencies. This will be very important. So my impression from Saudi Arabia, so I joined this Saudi-German Energy Day in Berlin. This was very well organized and pushed on the highest level. And they, let's say, lobby all of Europe to sign these long-term agreements. I've seen similar things in Egypt. So that's just my impression. I want to share my impression. So many countries are very aware of this new situation. And on the highest level, that means the minister level, they really push this. And especially the GCC countries and especially Saudi Arabia are very, very active, also with the NEOM project. Yes, I think this I all mentioned. So then I also want to show what does it really mean, this increase in hydrogen. So first of this is a report from the Hydrogen Council. And right now in 2020, we have 90 million tons of hydrogen, and it will grow to 660 million tons of hydrogen. This will increase 7 times. And it's also important to see how it will be used. Power generation, mobility, let's say building and industry heat, new industry feedstock, and existing industry use. So later I will talk more about this. So I think it's very, later I would like to talk about every industry a little bit, because the topic for this, let's say, presentation is what business opportunity exists. So they will be related to these industries. And another point, 3 weeks ago, there was a conference, or I would say a large and important conference in Berlin. And Dr. Kaufmann from ThyssenKrupp held a presentation, which I found very interesting. And ThyssenKrupp, which is probably one of the largest electrolyzer producers in the world, they expect 5,500 gigawatt electrolyzer capacity installed in 2050. So this is an unbelievably large capacity. So the next point, I also want to show that what we discuss is real. I just give some small, let's say, introductions, what has happened. So there was a very big agreement on the European level, let's say Germany and Belgium, Denmark. So Germany, or let's say the European countries, will develop a lot of wind and solar power, especially the North Sea wind power, and will produce hydrogen. And what I think is more interesting is you see these five corridors to Germany, and this is not a far away dream. So these will be hydrogen pipelines, and they are really in preparation stage. And when there is a discussion on a political level, like the conference in Berlin, this is something where the feasibility is conducted, where on a very high level, the politicians push this. So I just want to say this is a real thing that is happening. Another very important point is Europe. I show you Europe, and then you can think about Indonesia. I just spent a minute on it to give you a feeling what happens in other parts of the world. So Europe will have a dedicated hydrogen gas grid, and you see the pipes here. And when I joined the conference in Berlin, they announced the length will be around 10,800 kilometers only in Germany. So Germany will have a hydrogen gas grid, a backbone that will connect every region in Germany. So this will be really a key. That means hydrogen will be a key in the future. It's not a distant dream. And when I talk, or when I join conferences or talks in Egypt or Saudi Arabia, the people actually discuss these pipelines that connect North Africa to Europe. I mean, these are really hydrogen gas pipelines. So this is really in the making. It's not a distant dream. The next thing I want to share with you is there are a lot of hydrogen projects in the pipeline, but only 10% they have the final investment decision, the FID. And there was a very big problem in the past, and it still is, that the investor who produces hydrogen has a very long-term perspective. They need maybe a 10 or 20-year offtake agreement. Otherwise, they cannot do the investment. But the buyer, the purchaser, they want short-term. So this was a very big limit for to make investment decisions in the past. And then the German government has set up a non-profit organization. It's H2 Global Foundation. This foundation was mentioned this year in every conference I visited, and all the participants were very happy that they have been set up. And what this organization or this foundation is doing is the following. They conduct biddings, but the biddings have basically they cut two things in half. On the purchasing side, they buy hydrogen or they buy the derivatives, and this is a real business. For example, to deliver hydrogen to the port of Rotterdam. And this bidding is for 10-year purchase agreement. That means the one who participates in the bidding and who wins the bidding has a fixed agreement for 10 years. But on the buyer side, in Germany or in the Netherlands or wherever in Europe, the agreement is only 1 year. They do the bidding for 1 year. So this organization in the middle takes over the risk. It takes a risk, but by doing so, it can establish the market. It can really have biddings where people can participate. And let's say the first bidding has been conducted on the purchasing side, and the next bidding for the buying side will be conducted soon. And when during one conference I joined, the CEO of this conference mentioned that he is invited to Japan to introduce this organization to the Asian market, or at least to Japan. And this is one message I have today. When we talk about business opportunities internationally, for Indonesia as a country and for Indonesia as let's say companies, this is very important. You should, this is my recommendation, think about this organization, learn about this organization, try to, I'm not sure what has happened in Japan, but this could be applied either expanded to Asia, or Asia has something similar, because then Indonesia can, let's say, set up projects when it comes to exporting energy to Japan or Korea, but you will have the same problem. So this is what I wanted to share with you. The next one, now we come more, what are the more precise business opportunities? And this is also based on the report from the Hydrogen Council, but it was shown by Dr. Kaufmann of ThyssenKrupp in Berlin. And I thought it's a very nice, the way he displays is very nice. So I use the same layout. So basically, internationally, 90% of the discussion are based on these things. So, which is industry feedstock and chemical feedstock. So you have refining, you have ammonia, and you have steel. So in the international context, these are the big topics that are discussed. And the reason is these industries will need hydrogen. It's very difficult to have, let's say, a replacement that is not hydrogen for these sectors. And when you see steel, it only needs a CO2 price of $50 per ton. That means steel, green steel, will be cost competitive quite fast. That's the reason. Maybe just another note, in Saudi Arabia, for example, they have a very, very big push, not only to export energy, they want to produce the products made of green hydrogen in Saudi Arabia. And one focus is green steel, also green ammonia. And this, I think, is also interesting for Indonesia. Why only export energy, right? You also want to establish your own industry. So,
Stefan, sorry,
yes.
1 minute remaining. 1 minute remaining, Stefan, please.
Shall I continue or? 1 minute remaining. Okay.
Okay.
Okay, so I will hurry up. So I also want to talk about some other things. So we talked about green hydrogen, also let's say for new industry feedstock and also building and industries. But we as a company, we focus more on the other part, which is power generation and heat for building and industry. And for this, we strongly promote stationary fuel cell systems because they have the full use of electricity and heat, they are very efficient. And with the heat, you can also do cooling. They are very close to the consumer. That means there are very few losses. And they are very dynamic during the operation. That means they can change the load within seconds. By doing this, they can stabilize the power grid. I think this is a very big concern for PLN or other grid operators like in China. So we need to have a component in the future that can be centrally controlled and produces power on demand. We think fuel cell system will play a very important role for this. And just to give you some applications, fuel cell system can be applied anywhere where power, heat and cooling is necessary, commercial public buildings, industrial parks. They can be for emergency power supply or for peak shaving activities. And maybe another very important thing I want to mention is because in Asia, you still construct new regions, new areas, like new suburbs. So we strongly suggest to include the hydrogen infrastructure in the city planning. That means hydrogen gas grids, how to produce hydrogen, how to use hydrogen. It can be connected to hydrogen-based mobility. Once you include this in the city planning, you set up the infrastructure for the future. And you also help to attract new industries. And this infrastructure will be able to use maybe even for centuries. We have two of such projects where we design the hydrogen infrastructure for the whole area. This is a 65 square kilometer area in Guiyang in China. So just a conclusion. So let's say the old energy infrastructure for import and export will vanish. It will be partly replaced by hydrogen and its derivatives. This is pushed on the highest level, and I just want to, let's say, make everyone aware of that. The other countries are very active in it. I think Indonesia has a very good geographical location. It is much closer to some export markets than, for example, Australia. My personal impression is most of the business will be decided in 5 to 7 years. That means the agreements will be made. It's just my personal private opinion, what I can see. So I think it's good to act fast. I mentioned the H2 Global Foundation. I think this is a very important organization. It's good to make familiar with it. It's also good to focus on, let's say, hydrogen for power and maybe heating and cooling, like mentioned by Beni Adi in his presentation. And finally, I strongly suggest to include hydrogen infrastructure in the city planning so that you really build the infrastructure for the future. Yeah, thank you very much.
Thank you. Right, gonna call the second speaker, Mr. Nick Stansos, Asia Pacific Hydrogen Certification Lead at TÜV Rheinland. Mr. Stansos, this virtual stage is yours.
Yes, hello everybody. I'm happy that Stefan is also from Cologne, so we keep the geographical correlation the same. Can you see my slides?
Yes, perfectly.
Okay, hello everybody. My name is Nick. I'm based in Singapore, and today I would like to talk to you a bit about green hydrogen and, of course, hydrogen derivatives certification. I represent a company called TÜV Rheinland. We are a third-party independent testing, inspection and certification company, 150 years old. We celebrated that last year, and we're based in Cologne in Germany. That's why we're just by the River Rhine, and that's why we're called TÜV Rheinland. We have been active in Indonesia for a long time, I think for decades. We have strong offices there in quite a few locations. So we could also have a nice discussion over a tea or a coffee locally as well. I don't have a lot of time. I'll share the slides with you, but let's go to the certification. And I would like to give you some ideas to take away and think about it. The first one is that, of course, when we're looking at hydrogen projects, we see that we could have purely greenfield projects where everything is new. And if you like, from the beginning, this is designed as green. And of course, in that case, the certification might be a bit easier. But there's also a scenario where existing technologies and existing assets are going to be retrofitted, changed, and repurposed into this new or relatively new technology of green hydrogen. And as you can understand, that could create some complications in terms of how exactly we can monitor and we can verify and we can certify the greener component. Imagine, for example, you have a typical nitrogen facility where nitrogen is generated and it creates ammonia. And into that, we could add a component which is a green hydrogen component as a new one. But there will be two streams. There will be green ammonia and gray ammonia sharing some of that infrastructure. And of course, that could create some challenges on the certification. Now, why certification is important? I have here a long list, like, for example, it can demonstrate a commitment to sustainability, it can help the bankability of the project, etc., etc. But for us, and the way we see it is that mainly is a market access enabler, meaning in the future, you might not be, most probably you will not be able to sell hydrogen to another market, except if it is green or certified under a scheme there. And of course, certification will give you that ticket to be able to sell your green hydrogen. Therefore, it will create a market and will give access to that market for you. Also, maybe relevant in Indonesia as well, because you just started having your carbon exchange. I think it got live about 1 month ago. If a facility has recognized and certified green hydrogen, that might help the facility avoid or reducing penalties in regards to CO2 taxes or CO2 certificates. So it could also help you save some funds there. Now, in TÜV Rheinland, we have identified that there is a gap in the market in terms of a hydrogen certificate standard. because at the moment we have not agreed on a global common approach. So we have developed our own standard since 2021. And I would like to discuss a few of the principles of that, not only because I would like to advertise it to you, which of course I would like to do in a certain extent, but also to show to you that some of these building blocks of the standard are very similar with some other standards that they're in the market. And the first thing that I would like to highlight is the product carbon footprint, the PCF. Now, in every certification project, we will need to calculate what is the emission factor of the product hydrogen that comes out of the facility from a cradle to X, meaning X could be a gate to sell it, or it could be a transportation point, or it could be another process point in the supply chain. The idea is that we need to calculate all the direct and indirect emissions associated with any kind of material and energy flow coming into the boundaries of the system that we consider for our analysis. We follow a mass balance approach. And in order to calculate this, we use established tools, for example, ISO standards on greenhouse gas accounting, life cycle assessment, and general environmental accounting. Now, an innovation we bring in our standard is the issue of compensation. You can have the opportunity to compensate for the remaining emissions left into your process in order to reduce your total emissions into zero. So we accept that for our standard, as long as if, for example, you do indirect compensation, you would have to purchase some offset certificates from internationally accredited and recognized programs like VERA, Gold Standard, the CDM, or in Europe, the EU ETS. I'll come back to that. So when we see the calculation of the PCF, the product carbon footprint, you can see here on the top, we have the different stages of the supply chain. For example, the resources that come into the project, the production process, any transportation and storage, any need for conversion of the material for the creation of the fuels, and of course, in the end, the final utilization of the fuel, either by combustion or by creation of future cells. So depending on the needs of the client and depending on the boundary of the project, we could be able, for example, to calculate, as you see here, a PCF of 1. So here, for example, we have cradle to the gate that we call it X1, which could be a company up to the production stage, creating the fuel, and then selling it to another company which will be trading or purchasing it in another country or another region. So we could calculate, if you see PCF1 up to that gate, and then there could be an additional calculation to cover the remaining of the supply chain with a different owner there, or it could be a well-to-tank approach where basically from the beginning all the way to combustion, we could calculate a PCF value. Of course, as I mentioned, compensation could be also used. So we could calculate what is the PCF value, and if the owner of the process would like, it could purchase carbon credits or do some other direct emission reduction activity on the site to compensate the remaining PCF emissions and then create a value of 0. Now you're a bit familiar with the colors, and of course we have gray hydrogen that comes from a fossil fuel feedstock and using a reforming technology like steam reforming. We have turquoise hydrogen, where it is a pyrolysis of hydrocarbons that could be either fossil but also of biological origin. So it could be theoretically a pyrolysis of methane coming from a biological origin. And of course, green hydrogen that has to come from electrolysis. Now, in terms of the numbers, we follow the methodology based on the Renewable Energy Directive 2 in Europe, that is. So in order to calculate a benchmark for the PCF value, so in terms of the value here, we have a definition that we need to create a fuel that saves at least 70% of the greenhouse gas emissions in comparison to a typical fossil fuel value, which is defined in the RED II directive. The value there is 94 grams of CO2 per megajoule in terms of thermal energy. Now, if you bring that to a 70%, that means that any hydrogen fuel will have to be 28.2 grams of CO2. If we consider the energy density of hydrogen as 120 megajoules per kg, then we define that the maximum PCF value in order to be considered green is 3.384 kg of CO2 per kg of hydrogen. So this means the maximum, yeah? So in order to qualify for it, it has to be 3.384 and below. With a similar approach, we can do a calculation for other hydrogen derivatives using the same methodology. For example, ammonia could be a case. Now, in our standard, we use three main categories. So we call renewable hydrogen, low carbon hydrogen, and carbon neutral hydrogen. So if we go to the renewable hydrogen and follow, of course, the 70% reduction there, we have the green hydrogen as a scheme there, where we have to achieve the benchmark I just mentioned, the 3.384. And of course, for the green hydrogen, we have to use electricity coming from renewable energy sources and use the electrolyzer technology. We can also have what we call RED II compliant hydrogen, where basically, again, it could be used, it should use renewable energy, but also we have some additional parameters, for example, a temporal and geographical correlation, and also we have an additionality. I think that we don't have enough time to go to very much detail on that. Maybe we can discuss it later. Then blue hydrogen could be a part of what we call the low carbon hydrogen, if you like, scheme. Blue hydrogen is basically a process where we don't have a specific requirement on the hydrogen production route. It could be anything, but the CO2 coming from the process has to be captured and or permanently stored and utilized. Turquoise hydrogen, we saw it before, and it uses a different technology, which is pyrolysis. But the elemental carbon that's coming from it should not be converted to CO2. And pink hydrogen is the one that is using electricity from nuclear sources. Carbon neutral hydrogen is something that could be all the hydrogens we described before, but we have offsetting for a part of the PCF emissions that we calculated before. And this offsetting could be done indirectly from the use of certificates or indirectly with a direct emissions reduction in the facility. Here also I have a slide which summarizes all these different schemes and the play between technologies, the benchmark requirements, and also what you should do with any CO2 byproduct in the process. Now, in terms of the certification process, if you are familiar with ISO, it's something very similar there. So generally, there is a submission of the required documentation where we look at things like the process flow and the process diagram and the facility. We have to map all the direct and indirect energy flows and material flows coming in, and any kind of CO2 loads from any materials, upstream chains, different inputs from existing processes, etc. Based on this submission and this information, we're going to calculate the PCF value and create, if you like, a calculation based on that. This will be done mainly as a desk study and desk exercise. Then we follow with an on-site audit or a remote audit using some goggles or some other technologies, where we actually confirm the flow of the potential project And we verify any flows of material, looking at the pipelines, looking at the flow meters, looking at actual monitor data on the material and the mass balance. This would create some issues, most probably. We call it non-conformities. And then you as a client or project developer, you have to work with these non-conformities to address them to a satisfactory extent. If this is satisfactorily solved, these non-conformities, then an audit report could be issued, and then a certificate could be issued that has a duration of 1 year. Now, the important thing is that the certificate is not only mentioning something like, okay, you have green hydrogen, but it has the specific calculation, the specific number for the PCF value, because we recognize that project developers really need that and they want it. They want to have an official third-party recognized number of what is the PCF value of the project. Now, I think I'll stop here because I don't have much more time. I will share this presentation with you. We'll have a lot of case studies that might be inspiring for you and give you an example of how we could help you develop your project and certify it. Thank you.
Thank you. Thank you, Stansos, for your presentation. I'm going to call the third speaker from PLN. Already joining with us, Mr. Ricky Cahya Andrian. He's the Vice President of Business Development from PT PLN Persero. Pak Ricky, this virtual stage is yours.
Okay, thank you, moderator. Let me share our presentation. Wait. Sorry about that. Okay. Okay, I try to. Okay, already see ya, Pak Moderator. Okay. Okay, let me start. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Best wishes to all of us. Thank you for the invitation to the webinar from Econet. My name is Ricky Cahya Andrian, VP Business Development PLN. On this event, I will try to share what PLN has done and will do regarding the green hydrogen. These are some of PLN immediate plan for the future. We have already 9 October 2023 inauguration. We have first green hydrogen in Muara Karang, attended by the Director General of ABTKIE. And 20 November next week, we will have inauguration of 21 green hydrogen plant belonging to PLN. Hopefully, the Minister of Energy will be able to attend. This is the, I think, the most hydrogen plant one level below the Chile, which have 22 S2 plant. In December, we also inauguration for the first energy production from the fuel cell generator, which uses the hydrogen fuel taken from the Muara Karang. In the same December, we will have some inauguration of the S2 refuel station in PLTD Senayan, whose hydrogen is taken from the Priuk in Notanpan, Jakarta. In February, PLN is planned to sign an MOU related to development of our Nusantara High Park. It's a kind of a hydrogen park in the IKN, New Capital City of Indonesia. In March, we have inauguration of first green ammonia production collaboration with Pupuk Indonesia. And then in April, PLN will have a GDA with Semcop regarding plan to export hydrogen to Singapore. And then the next month, PLN will sign with several off-taker domestically and globally. PLN has succeeded in making history on Monday, October 9th, 2023 by operating the first green hydrogen plant in Indonesia located in Muara Karang. This plant has an excess production capacity of about 43 tons per year. And then to make this green hydrogen, the electrolysis is supplied by the PV rooftop, PV ground mounted, and floating, and also from the grid, which uses the renewable energy certificate. This kind of renewable energy processes in Muara Karang is come from the PLTP Kamojang geothermal. Apart from Kamojang geothermal, we also have from the Lahendong in North Sulawesi, Bakaru in South Sulawesi, and Ulubelu in Sumatra. This is kind of example of renewable energy certificate, Muara Karang from geothermal Kamojang. This is the example of a single line diagram of the example of one of our power plant in Lontar. auxiliary transformer. You can see that if you want to install the new electrolyzer, the potential spare power to is around 22 megawatt, or the equivalent to production about 2.5 KTPA, which will get the special price because we use the excess power, and we also get the free Demin water here. And then sorry. Sorry about this. And then this is a price structure of hydrogen plant gate. Yeah, you can see that we have a sensitivity of price. Yeah, if we can show you the if we build in the power plant, yeah, we can get about 2.87 USD per kg. And then if we build an H2 plant far from HRF or offsite TRS, then the landed price with tracking is around 4.71 USD per kg. But if we build H2 refuel station at the generator location on site, then the LCOH price is around 4.13 USD per kg. This is a Muara Karang green hydrogen plant scheme will be rolled out to 20 other locations to achieve PLN target of 21 location on next week. And this is the location of 20 green hydrogen plant in Java and one more in Sumatra in Pangkalan Susu. And this is the existing green hydrogen plant. PLN committed to reduce carbon emission about 8.8 kiloton CO2 per year. And this is Greti solar PV for the green hydrogen plant supply. And this is the solar PV capacity in Priok, 43.6 kilowatt peak, and this is Pemaron, 96 kilowatt peak. This is Tambak Lorok, 561 kilowatt peak. And talking about the hydrogen mobility, this is what PLN do for building the hydro refuel station. The hydrogen comes from the Muara Karang or Priok in the Northern Jakarta. And this is the location of S2 refuel station which PLN want to install. There will be a Senayan, Muara Karang, and Priok. This is in Jakarta, and we hope that there will be supply hydrogen refuel in Jakarta. This is the location of S2 refuel station in Senayan. This is the layout. And in Senayan, we will have a BEV charger and also HR. This is a Muara Karang. Yeah, this is Muara Karang. And this is kind of, we will have a BEV charger and S2 refuel station. Both of them will be supplied from hydrogen. For the BEV, we use the fuel cell generator. And then this is the pallet we will use to fulfill the S2 refuel station. If the off-taker rising, we can change into the two-trailer tank. This is the tracking to transport from Muara Karang and Priok to the HES Senayan. This is the indicative price. So for the onsite investment, it means that we build together electrolyzer and dispenser in the same place. The LCOH plant gas is about 4.14 USD per kg. If the offsite is about 4.71 USD per kg. So if we use the existing electrolyzer, it means that we also have also the byproduct Demin water, so we can get a more lower price is about 2.29 USD per kg, and with the tracking is about 2.45 USD per kg. So if we compare to the gasoline, we can conclude that for being competitive today, the price of hydrogen in Jakarta is about maximum 3 USD per kg. This is the gasoline and diesel price November from the Pertamina. And this is the price what I found in Brisbane is about 15 USD per kg. So if we install the electrolyzer near the power plant, besides we use the free Demin water by the product, and also we can use the excess power from the power plant. So we have a competitive LCOA. The price can be around 2.29 USD per kg for onsite, and offsite around 2.45 USD per kg. This is a kind of price list of hydrogen in several countries. The source is from the Argus Media. And this is the full cell generator. We will have it in Jakarta in about December from Toyota. Now the position is in shipping from the Perth to Jakarta. And we will show to the people of Indonesia, the audience, that the full cell will be powered electricity in Senayan and also Monas. And this is a kind of fuel cell, which we will have in Jakarta is the input is 15 until 200 bar using 4 kg H2 for producing 80 kilowatt hour around 11 meter cubic. And about ammonia, what we will plan do, we have a cooperation with the Pupuk Indonesia. We have a GV for the green hydrogen plant or also green ammonia production. This is the supply chain of ammonia which PLN would use to co-firing in Muara Karang. And Pupuk also can also be the off-taker to use by their own use. This is the project of co-firing which PLN has already started. We will continue again and finding source of hydrogen we will produce. And then this is the beginning of producing green ammonia. PLN will transport it from the Muara Karang trucking to the Pupuk Kujang. Yeah, is about 1 hour and 43 minutes. And this is a kind of PLN substation near the Pupuk Kujang. We together with Pupuk, we will build the electrolyzer near the substation and piping to the to its ammonia plant. And about the industry decarbonization, there are the location of this is a location of substation PLN in West Java, Banten, and Jakarta. So every places there should be a substation. In every industrial cluster, always be a substation of PLN. If we build some electrolyzer, we can shorten the transport and open and speed up the decarbonization in every industrial cluster. This is Jababeka, Pulau Gadung, Batamindo, Surya Cipta, Cikarang, MM 2000, and then this is Kendal, Makassar, Dumai, Karawang, Medan, and this is Cilegon, Semarang, and this is the example of Karang Industrial. PLN has a Pinayongan substation at there. And then in Karawang, PLN also has 2 other substations. So we have totally 3 substations to feeding the Karawang Industrial. And about the utilization of fuel cell for the digitalization, emphasize PLN's commitment to hydrogen utilization. PLN has about 5,258 unit diesel genset in 2,130 locations scattered, and the capacity are about 2.3 gigawatt, and the energy produced are about 3.1 terawatt hour annually. The decision can apply fuel cell because fuel cell are hydrogen utilization which can produce electrical energy without emitting CO2. If the total energy generated by diesel power plant is about 3.1 terawatt hour, then the potential of hydrogen utilization is about 93 KTPA hydrogen. So, and then this is ADF and PLN cooperation. The MOU was signed between PLN and SDF in Paris and witnessed by the Indonesian ambassador and French minister on April 18, 2023. There is many support from the stakeholder to strengthen the MOU between PLN and SDF, such as Ministry of Energy Mineral Resources, Bappenas, Governor, and also Sumba and funding institution. And the renewable power plant concept is an renewable energy based power plant with power supply configuration through cascading utilization of PV, battery, and also fuel cell. PLN still have many diesel power plant in many islands. This is the example in Sebira Island, 100 km north tepat Jakarta from Muara Karang in Kepulauan Seribu. And we will replace the diesel with the fuel cell using the green hydrogen. And talking about the export, GDSA hydrogen export to Singapore through cooperation between Sembcorp and PLN. PLN and Sembcorp will build a hydrogen plant and export to the hydrogen to Singapore through piping from Sumatra. The signing happening in the Singapore Energy Week last 24th October in 2023. And the power supply for the electricity is come from the grid 500 kV, also using the renewable energy certificate. This is kind of hydrogen price in several countries. And also this is kind of ammonia price in several countries. We can see that Japan and South Korea is very promising market for the export. And this is green hydrogen and green ammonia price plan get from this table. We can see that if using tariff E4 in PLN around 6.4 cents, then the ammonia is around 750 USD per ton. I think it's very still competitive because the price electricity in PLN is lower than others. Thank you very much. That's all our presentation. We go back to the moderator. Thank you.
Thank you, Pa Ricky, for your very interesting yet very fast presentation. Okay, I think gonna go straight to the questions or comments that came from the audience. Okay, let me see. Okay, at the moment there is no yet questions from the floor, so I'm gonna take the liberty to okay, there is already one in the chat from Pak Bayu Aji. The question is addressed to Pak Ricky from PLN. Pak Ricky, has the hydrogen plant running? The solar PV installed are in kilowatt size, but the plant is producing hydrogen near to coal power plant. Okay. Also, how PLN sell the hydrogen for the fuel cell while there is no fuel cell running in Indonesia? Maybe you can answer this question dulu, Pak. Silakan, Pak.
Pak, sorry, I didn't hear the first question, but the second question about the fuel cell, yes, you are right. I believe that there is still no fuel cell in Indonesia. That's why PLN will bring it to Jakarta, yeah, next month, and we hope people in Indonesia can see we have a fuel cell generator as an alternative to replace the diesel, Pak. It's very clean because there is no emission, only water as an emission. Thank you. And the first question, can you repeat, Pak? Help me. First question.
Apakah the hydrogen plant already running, Pak? And
okay, yeah.
You have solar PV installed in the hydrogen plant, but questioning the electricity source for the plant, Pak, whether you use it from the coal power plant or from the solar PV installed.
Okay, thank you. The hydrogen plant are already running. Already running because now the hydrogen the function is for the cooling generator in each plant. So we try to optimize the excess hydrogen we can use for other utilities like for the transport or maybe for the fuel cell for replacing our diesel power plant in many islands. And the concept is we supply the electrolyzer using two sources. The first one is come from the PV rooftop, PV ground mounted, and then PV floating. We installed it in the power plant, and then the second is come from the grid, yeah, using the renewable energy certificate. That's why this is a very competitive price because if we install it and come from the auxiliary transformer, the price is considered only to the componency, yeah. So if componency, it means that we don't calculate component A or B, right? So we can get the competitive price, and we do it in cold steam and then in the in the gas power plant. That's my question, Pak.
Okay. Okay. There is question for. I think this is addressed for Nick Stansos from TÜV, from Mr. Ridlow. Is there a methodology that can be used to calculate the PCF value? And from Pramod, yeah, still for Stansos, do the certification scheme accept the use of renewable energy certificate as green hydrogen or renewable hydrogen? Please, Stansos.
Yes, okay, thank you. So for the methodology, we're using the ISO standard, which is on greenhouse gas accounting. Yeah, so we follow a typical approach there. So we don't use something innovative or different there. Is a typical approach. For the use of RECs, yes. So if you want to certify, let's say, as green hydrogen, you could have your own renewable energy facility with direct link, or you could have a link with the existing grid through a PPA, or you could use grid electricity, but for the emissions associated with the grid electricity itself, you could compensate them by using RECs. But these RECs, they have to come from the same country. So we need to have a kind of geographical correlation there. So it has to be RECs issued in Indonesia, cannot be RECs, for example, from India. So that is a limitation. But yes, you can use RECs.
Okay. I think I have one question for Stefan. My question is, in your perspective, what are key elements, Stefan, that are needed to be reformed for developing countries such as Indonesia to enable them to expedite green ammonia production or development?
Okay, so I think one, okay, that's actually a complex question, but let's say, I think one important key is to link to this H2 global. I mean, to understand it better and to see how you can expand it to Asia, because this opens the market, like the client, that you find client, right? The client is the starting point. And then I think it's also, what I see in other countries, the strategy is to build up new industries. I mean, really from the let's say ministry level, from the high government level, that all the let's say the government officials, also with their policies, try to support not only export, for example, hydrogen, but also the products of it. So I think this is, and then additionally, that you require local production. I think many countries try this, like China, maybe the most famous, that they have done that very successfully. But if you have, let's say, these large projects, also from PLN, right? From PLN, you have many projects in the pipeline, and we are also maybe trying to develop a project. But I think this is, I would suggest, like local production to request it. Maybe just try to say this simple.
Right. Thank you. Maybe last question, Pak Ricky. It's from me. The question is, what price of hydrogen, Pak, PLN expect to be sold to customer? You already have the calculation of the production, I guess, and the price of the hydrogen for you to consider this is a good, economically good project for the investment, Pak Ricky.
Yeah, thank you, Pak. As you know, we have been have intelligent marketing to know what is the price of landed price like in Japan and Korea and Singapore, right? What we know that in Korea is their aspiration maximum about 5 until 9 USD per kg, right? Landed price. And Japan and Korea is about 6. Sorry, in Singapore about 5 until 6 USD per kg as their aspiration, what Semcop want, and then in Japan is about 6 until 7. Yeah, also with Korea, 6 until 7 USD per kg. Because when you see the H2 reforestation in Japan, the price is about 8 USD per kg. That's why we can show you that the hydrogen produced from PLN is very competitive. You can see that if we buy from the grid PLN, yeah, using from the high voltage transmission, is about 6.8 cents per kilowatt hour, including the REC. It will be produced LCOS about 4.4 US per kg, Pak. So if you this is for the plant get. If you transport, yeah, you can adding, let's say, 1.5 USD per kg, still competitive price for the landed price in the Japan and Korea. That's Pak. Thank you.
Okay, thank you. Okay, ladies and gentlemen, I think we already hit the time marks. We passed 5 minutes from the original schedule. I thank you very much for the speakers, Mr. Stefan Duch, Mr. Nick Stansos, and Pak Ricky Cahya Andrian. Thank you very much for it. Okay, we wish you all a very good luck for your future
thank you very much.
Right now, we continue to our next session. All right. Continue to our next session where we have speakers from already joining us from PT Pupuk Indonesia. Already joining us, Mr. Wait a minute, Traino Joko. He's the project manager at PT Pupuk Indonesia Persero. With this, I give this virtual stage to Pak Traino. Silakan, Pak Traino.
Okay, thank you, Pak Rico, and ladies and gentlemen. So let me introduce my name. My name is Traino. So I will to share our presentation. So already open. So we will present a good afternoon, ladies and gentlemen. My name is Traino. So I representative from Pak Rozikin Russo as a SPM Green Energy and Blue Ammonia. So this seminar we have some the title Beyond Green Hydrogen Exploring Derivative and their fields, application and markets. So next. For the Pupuk Indonesia, we will to explain first for the about the Pupuk Indonesia. Pupuk Indonesia is the largest fertilizer producer in Asia Pacific and Middle East and North Africa. So we produce the ammonia around 7 million tons per year and urea. So our big product is around 9.3 million tons per year. So we have some 5 facility for the fertilizer plant, and then non-fertilizer plant we have some 5 company. So for the decarbonization initiative and green business development to drive sustainability, at the moment we produce the gray ammonia. Also we the ammonia we use the ammonia going to the fertilizer as a urea. And then the future we have the project about the blue ammonia and then green ammonia. So this is the ammonia is the future chemical to get the decarbonization program can be established in the future. So this is the hydrogen uses in industry. The global hydrogen demand in industry 2015 until 2030. So around more than million tons hydrogen demand in the world. Yeah, so this is potential business for the future. And the moment for the 2050, around 300 million. So this is expected to use for the NZA scenario for the demand for the power and road transport, also in the marine fuel. So Papua Indonesia has potential roles clean ammonia value chain development. The moment we use the ammonia for the urea, or the moment for the urea is not the product for the decarbonization initiative because the urea can release the CO2 in itself. So we have to change our development as like a blue ammonia or green ammonia as another fertilizer using like ammonium nitrate or green fertilizer. Also for the ammonia as like Saya said you can use for the fertilization and power plant, and then for the hydrogen the ammonia we can cracking the ammonia into the hydrogen and use to the green steel for the furnace. So this is our project development like bunkering in Aceh to get some demand in the marine fuel. So this is potential in special economic zone in Lok Sumawe. This is a competitiveness of the clean ammonia that at the moment CO2 price in Indonesia around $2 per ton, and then renewable grid electricity cost we use the PLN grid around 6.6 until $6.8 per kilowatt. megawatt hour. So the CO2 price for the competitiveness, we have to upgrade until 30 USD per ton CO2. Yeah. So to get some competitiveness with the hydrogen from the natural gas price without the CCS like as SMR, and then also we have to explore more development and another process like ATR, auto thermal reforming. So the key enabler is from Pupuk Indonesia is partnership for business development, energy resources, and then develop capability, technology association, and government support. So this is our forecast for the demand project in the 2060. So in the 2060 around the 200 million. So this is a very big from the shipping, and then from the power 82 ton, and then the fertilizer maybe decrease 20 million ton per annum. So in the right side in the graphic, Pupuk Indonesia until 2060, we around more than 10 million. From the biggest is the green ammonia around 7 million, and then blue ammonia 44 million, and then gray steel for the urea around 1.6 million. So the key success factor for the clean hydrogen and ammonia development is 5 points: safety and awareness regarding for environment impact, economic feasibility study, green energy requirement, and then readiness for the technology and infrastructure. So capabilities development and technology acquisition as one key enabler for clean hydrogen and ammonia. So we built this with the partners with solar farm, wind power, and then we elaborate with the good electrolysis technology, and then we have collaboration with the technology, the capturing, and then CCS reservoir, and then another IPP like geothermal, and then the technology with the ammonia cracking, and then the ammonia as a fuel. So regulation requirement in Indonesia for the clean hydrogen and ammonia development. So mainly from the ESDM, from the MEMR, and then for the Environment Ministry, we have some 7 points until 2025. Many regulation in here, and then the 2030 like a carbon footprint accounting for the carbon is very important. So we have some kind of project, the blue ammonia, which is our focusing for the blue ammonia in Aceh. We will develop a 2,500 metric ton per day of the blue ammonia in PIM, which is the 3,250 metric ton per day we can inject to our CCS reservoir in Arun. This is the recover reserve is around 15.6 TSCF. This is equal 800 something million ton for the CO2 equivalent. This capacity still 3.3% in the Arun field capacity. So the Arun field is good place or good location for the CCS hub in the at least in the Southeast Asia. And then for the green hydrogen and green ammonia, so we want to as a pioneer, we collaborate with the PLN also in Aqua Power. The scheme is we have some wind power and solar panel. We use the grid from PLN, and then we build the hydrogen electrolysis, and then inject the hydrogen in ammonia existing petrokimia Gresik in East Java. So we develop around the 200 megawatt, and then from the solar around 600 until 800 megawatt, and then we estimate produce in around 500 metric ton per day in petrokimia Gresik. The COD for the blue ammonia 2030, and then for the green ammonia maybe earlier to 2029. So the challenges of the recommendation for the clean ammonia development is first regulation from the regulation of the CCS and regulation of the related to CCS hub. And then power wheeling policy, fiscal regulation, guideline regulation standard and for clean ammonia, GHG emission regulation for clean ammonia fuel in powers and our shipping sector. Also, we challenges in the ammonia bunkering or fuel loading guidelines and regulation. For economic factor, we know the high capex and opex, so we need some support like incentive, easy access to green financing, competitive carbon pricing, and to monetize carbon, renewable energy integration with the green ammonia plant. And then for the technology, the high technology costs require further research that focus on reducing or optimizing CCS and electrolyzer costs. And then selecting the right technology. So then the last is the lack of infrastructure availability. So we need some require development of the ammonia bunkering and then require development of the CCS hub. So this is our presentation.
Right. Thank you. Thank you, Mr. Traino, for the presentation. And I'm continuing to our next speaker. Already joining with us, Dr. Stefan Gunther, Team Leader Next Gen at Solar Belt Fairfield. Please, Mr. Gunther.
Yeah, thanks a lot for the kind introduction. So thanks a lot for inviting me to that talk. I'm just start sharing my screen and you should be able to see it now.
Yeah, perfectly.
Okay, so thanks a lot. So I'm talking about power to liquid and biomass to liquid pathways for sustainable aviation fuels. So just to give an outlook, I want to first say a few words on the defossilization of the aviation sector in the EU. Shortly say a few words on my company and then go into detail about the power to liquid and biomass to liquid pathways. And in the end, sum up with a few words on the sustainability for the feedstock that is needed to achieve really sustainable aviation fuels. So in Europe, the legislation on European level is quite advanced. So there is an agreement to have mandatory sustainable aviation fuels blending quota. So it's agreed by beginning of the year between the European authorities. And it will be mandatory to have in 2050 something like exactly 70% of sustainable aviation fuels blended to conventional jet fuel. And then the point is there will be high fines for European aircraft operators and also aviation fuel suppliers if they cannot fulfill the blending quota. So there are really the jet fuel demand is still increasing in the EU. And what you see is the demand, the blending quota for the SAFs is coming increasingly high. And it's still a limited feedstock available for paths like HEFA routes or similar. So the EU has really very ambitious regulation, and it will be the case that it's at least our opinion that every liter of sustainable aviation fuel that will be produced in the EU will be consumed. So and then the fines for the not fulfillment of the blending quota will be the price benchmark. So we from SolarBelt, we are a quite small company. We see ourselves as project developers, but also investors and operators of plants. And then we also have access to market for SAFs, but also for SAF certificates. We have an own certificate standard. And our target is really to make the jet fuel industry climate friendly. and we are following in our approach to have a sustainable business, which means we are investing each euro which we are gaining, we are investing into new technologies and into the fair partnerships with our partners worldwide. We are sitting in Germany, in Berlin, but we have a plant in Werlte in northern Germany, which is the world's first, at least we think that it is the world's first power to liquid plant, at least on a semi-industrial scale. So the plant, you can see here a picture of our plant. The construction is finished, and I'm happy to say that we're already producing the first liters of synthetic crude oil. We have a production capacity of 350 tons per year, which is still quite small, but it's, as you see, it's not so small that it's laboratory scale anymore. The main components are an electrolyzer from Siemens and from Ineratec, a German startup, is providing the synthesis unit. And we have offtake agreements for the output already in place with refineries, with airlines, and also with travel agencies who are taking off not the SAF, but certificates for SAF blending quota. So the production pathway is we are getting carbon dioxide from a nearby biogas plant. We have also a direct air capture module installed, but it's only supplying a small percentage of the CO2. We have an hydrogen from an electrolyzer, which means we use water, of course, and then we need the electricity. The electricity is coming from local power plants based on renewable energies, and that the output of that process is so that CO2 and the hydrogen is fed into the Fischer-Tropsch unit, and synthetic crude oil is coming out of it. But you have to upgrade the synthetic crude oil in a nearby refinery to make mainly jet fuel out of it, but you also have, of course, byproducts like diesel and naphtha and so on. So this is our power to liquid approach, but we are also thinking on biomass to liquid approach, in particular for countries like Indonesia, where abundant biomass is available. And we are proposing for that a gasification Fischer-Tropsch pathway. So it's basically 3 steps more or less in the biomass to liquid plant. So there is the gasification of biomass fed in. So could be residual biomass. So just a few examples. So could be coconut shells, could be rice husks, could be, of course, wood chips. The point is it has to be, of course, sustainable biomass, which means we should focus on residual biomass. It's gasified, which means synthesis gas is produced. It's containing carbon monoxide, carbon dioxide, hydrogen. Then, of course, you have to clean the synthesis gas and also have to condition it and take care that corresponding ratios of the constituents of the gas are fed into the Fischer-Tropsch reaction. And then out of the Fischer-Tropsch reaction, we have the same as in the power to liquid plant. We have synthetic crude oil, which can be processed in a refinery to make jet fuel out of it, but also in minor portions, diesel and things like that. So the good thing compared to the power to liquid approach is that energy is almost solely coming from the biomass itself. So you need only minor electricity but biomass is used for heating. The gas is for heating up the biomass itself to gasify it, and of course the energy contained in the synthetic crude oil is also coming from the energy contained in the biomass, which makes it so attractive for countries like Indonesia to have really independent from electricity supply. You can produce SAFs. There is already a there's already a 1 megawatt prototype available in Vienna. We are cooperating with a company that has built that plant. It's already in operation since last year. We are making there already trials to convert biomass into synthetic crude oil. So it has already quite high maturity level, although of course not yet commercialized. So and therefore we are thinking, we have project ideas for Indonesia to really think in the long-term strategy to end up in a commercial plant, which has then something like a dimension of 75 megawatts of input heating value, which could go into operation something like 2030, which should be, of course, commercially beneficial. But to reach that, it makes sense to make the upscaling in two steps. So start first with a smaller pilot plant, similar to the size in Vienna, to transfer the technology to Indonesia, to set up the logistics from the biomass till the refineries. And then if everything's working, you can scale up. So the current status is that the technology is demonstrated. We already have process concepts for plants, including mass energy balances, including equipment lists. We have promising business case in place. And of course, we have, based on the activities in Germany, interested off-takers and also engineering companies supporting us in that steps. But we are still searching for partners in, for instance, Indonesia to go with us that step into the future. At the end, a few words on the sustainability. So I'll just take the example of the power-to-liquid plant. So it's important that the feedstocks are all fulfilling strict sustainability criteria in order to reach green greenhouse reductions beyond 90%. So of course, this means the electricity has to come from renewable, local, and also additional sources. So don't take away the energy from the people. So you have to install additional capacities for doing so. If you are capturing CO2 from the air, of course, the necessary energy has to be green. If you're using biomass, of course, you have to be biomass that is sustainable and is not in competency with food production, for instance. So it should be typically have a residual character. And of course, if we're talking about water consumption here, for instance, for the production of H2, it also has to be taken in a socially and ecologically responsible way. So therefore, our sister company, Atmosphere, has developed a standard for certification of the sustainable fuels, which is called the Fair Fuel criteria. It's coming from that when we started our project several years ago, there were no regulations in place. So in the meantime, the European Renewable Energy Directive is released, and then in the next months, the procedures for that certification are being rolled out. Nevertheless, we will keep our fair fuel standard alive because it's in some aspects stricter than the regulations. We are also covering in particular social and also governance criteria. And the other point is we are allowing book and claim, which is not placed in the red. So also our plant in northern Germany is following that fair fuel standard, but of course also meets the RED II criteria. And if we are talking about the next years, it's important to generate value out of the SAFs. And the point is, when you have such a strict sustainable aviation fuel, which is certified via the fair fuel standard, you can, at least in the first years, reach higher income for the SAF compared to, for instance, HEFA SAF. And this is important for speeding up the technology, for generating income, for building new plants. So we think that the fair fuel standard is a good choice for the, of course, voluntary market. For the regulated market, please take the RED certification. So that's all from my side. Thanks a lot. And yeah, looking forward to your questions in the end.
Thank you, Gunther. Right, I'm going to call our next speaker, Mrs. Shirin Omega. She is the General Manager of Corporate Planning and Sustainability at PT Gunung Rajapaksi. Mrs. Shirin, this virtual stage is yours.
Hi, thank you, Bariko. Hi, everyone. I'm pulling up the screen. Is it visible now, Bariko?
Yes, perfect.
All right. Hey, so good evening, everyone. Good morning for some of us. Let me introduce myself. My name is Sharon Omega. I'm the head of sustainability for Gunung Rajapaksi. We were based in West Cikarang, West Java, in Indonesia. So in this great opportunity, I'll share with you how we as a steel manufacturing company looking at our decarbonization initiative and how we see green hydrogen application to our manufacturing process. So I would like to start with who we are. We are basically in the business now for 50 years now. We are one of the largest private steel manufacturing company in Indonesia. Our capacity is now around 2 million ton per annum, and we have around 4,000 qualified employees, whereby our market is now 95% domestic with 5% are export. Our product categorization came into three major category, which is the flat side, long side, as well as downstream. So if you see on the application, flat would be most towards the shipbuilding, the bridges, as well as infrastructure, as well as long. Long is more towards infrastructure, towers, and then various machinery as well. For the downstream, we're looking at the application towards the foundation piling, jetty construction, as well as concrete walls or floor. And our revenue record 2022 at $945 million worth of revenue, whereby based on product categorization, majority coming from flat, which is 69%, and our direct customer majority is coming from distributor profile. So in terms of products, as I mentioned, we have three major category products, and the application itself, I think for 50 years now, we've been supplying to quite well-known project. As you can see from the far right here, we've distributed, supplied to bridges, LRT, some power plant as well, and we're keep looking for new opportunity in this case. So I want to touch before on the decarbonization initiative, specifically on those aspects. I want to touch base on how GRP's growth initiative, basically, we're looking at ESG-driven strategy, how we want to enhance our sustainability topics as one of our key business strategy, as well as our company-wide multi-directional transformation initiative. So since I think for the past 3 years, majority of our activity coming from the business transformation, whereby we're looking at our business process, improving our process as well, in a hope that we can translate that into cost efficiency, more transparency, and increased governance level. Last but not least, of course, as a a commodity product, we want to have stability of financial performance as well as market growth that we foresee for the upcoming years, right? And now we're looking at the potential economic growth as well could also support GRP business moving forward. Specific for decarbonization and why, in a way, like GRP tap into this ESG businesses, more focus on ESG. We basically looking at three major pressure now. We now see government of Indonesia specifically started to be more active in terms of decarbonization, and through their enhanced NDC, they wanted to achieve more decarbonization initiative. Our investors as well, in terms of financiers, started to ask us basically what will company do in terms of ESG and decarbonization, right? Because we are indeed, as a steel manufacturer, top three contributor in the global carbon emission scenario. We're looking also at our value chain. We start with our customers, started to request sort of like data transparency of our product. But we also want to touch base on our supplier side because we believe though the nuance of climate needs to be end-to-end value chain. So we had the request from customer, but we want to also sort of like take the hand of our supplier to be together in this decarbonization journey, basically. So this page show you what are the challenges and decarbonizing our steel industry. Before I talk more on the hydrogen application in our business, basically first that we acknowledge a bit a challenge is the awareness level, specifically if we're talking about Indonesia market. Awareness about decarbonization, and then how do we apply this to local context, how the collaboration should be established between the value chain needs to be improved and enhanced, basically. So that's the first challenges. Technology availability, also one of the challenge that we foresee in the steel business, specifically on how one of the more promising technology is on the green DRI, where we use hydrogen-based processes. As of now, is the lowest carbon emitted in terms of steel manufacturing, but yet it's still majority on pilot project and not yet been scaled to the industrial level, right? That links to the economical viability, basically how this low carbon technologies basically being balanced with the higher cost. How does that mean translate to our cost, basically in terms of producing the lower carbon steel, and how basically the market receiving, how is that basically how customer accepting those impact of a new technology, right? And then I've touched base a bit on supply chain complexity. Indeed, steel business is quite traditional business in a way. We have a complex supply chain. We are a commodity, which means that decarbonizing our business requires sort of like coordinated efforts and a robust ecosystem to achieve our global goals, basically. So with that in mind, with those challenges, what we're trying to do as a company here in Indonesia is that we started with formalizing our sustainability department. So now we have dedicated people to lead this sustainability initiative in the company. With that, we also established our ESG roadmap last year, which is basically will guide as our guiding principle, basically to do this ESG implementation in our business. Following that, we're also launching our net zero roadmap, where this roadmap specifically talking on decarbonization and how we pledge our target, which is to achieve the carbon neutrality by 2050. A bit deep dive, I want to share with you what are those 5 core ESG pillars. The way we do this guiding principle is having interview with our stakeholder. Basically, we reach out to internal and external stakeholders. We talk with our supplier, our customers, our financiers, including a government as well, to understand what are their point of view in terms of us as a steel company in Indonesia have to pay attention to, right? So we come to the sustainability framework where the first pillar is touching on the responsible procurement. I touched a bit before our customers started to ask on the transparency, but we look at the urgency to sort of like educating and asking our supplier side to be together in this initiative so that we can ensure the environmental and social objectives are met throughout our value chain. Environmental and social compliance will look specific into how the company comply to the regulatory requirements, as well as managing the social and environmental related topics, which is guided by the global standards. The third and fourth pillar will closely related to the environment aspect, whereby the third is more towards how we explore the energy transition and low carbon solution to support the steel manufacturing, because we believe in terms of steel industry, it is required a new technology to achieve so-called green steel and low carbon steel, basically. Fourth, looking at the waste management side, how we manage our impacts and waste post the production side, and then how we manage those with transparency and accountability. Last but not least, on the social side is focusing on the talent, because we are committing to our people as our assets to provide them with the training, the right capability to basically work together with the company to achieve our vision and mission. Zooming into our net zero strategy, which supporting our third pillar on the environmental aspect, we're looking at how we switch our fuel consumption. Later, I will share you how is the carbon footprint in GRP, whereby majority is coming from scope 2, 75%, and scope 1 around 25%. And then how we're looking at our production improvement and cost efficiency, basically internally, in terms of how we manufactured our process currently. And then also looking at alternatives of green power sourcing, because this is quite related to our scope 2 footprint as of now. And then fourth pillar is looking at the reduction of our carbon. We're also considering offsetting those carbon emission in our product in order to achieve so-called zero or carbon neutrality steel products. Last but not least, again, collaboration and partnership. We still see this as a key major pillar to sort of like having this all together to basically, again, achieve these global goals to manage the 1.5 degree climate change. So what we are doing and what we can do now is that one of it is we installed the rooftop solar system. So in this case, we work with Total Energies since last year, where we enter into MOU, and then we've already finished our first 900 kilowatt peak by the end of 2022. And happy to share that it's now operating in our site. We are now currently at stage 2 of installation. And we're expecting by the end of the project, phase 3, which is estimated end 2025 or 2026 early, is that the total capacity will be 33,000 kilowatt peak, with the expectation to generate around 45 million watt hours annually. Looking at our energy consumption, this is not significant. Being open to you all, this is roughly around 10% or 7% from our annual consumption of energy or electricity, basically. And then the next, and I think more relevant to this webinar, is that we signed our MOU with Fortescue Future Industry, or Fortescue now, where we want to continue and strengthen our commitment to support Indonesia as well as our carbon initiative to achieve our neutrality by 2050. So we signed this MOU with them back in B20 event, whereby this MOU intention is to explore how is the green hydrogen can be utilized in our plant. And happy to share with you as well. We are now in the feasibility study process. We're still in the preliminary stage of the study, but what we can share with you is that what are the objective of the study, right? I'll start on the right side first. Right side here showing you our inventory calculation back in 21. So if you can see scope 1, like I mentioned, around 25 to 26% contributing, where our purchase grid electricity contributing to the 74%. This is because GRP as a steel player are using the electric arc furnace. So in terms of technology in the steel manufacturing industry, there are two category majority. The first one is on the blast furnace or iron ore, where it will emit more emission in a way compared to the electric arc furnace, because we're using electric, not burning the coal basically. So that's why our profile is majority on the scope 2. So on this study itself, the primary objective is to focusing on our pillar 1 in our net zero roadmap. We want to focus on scope 1 emission first, because scope 1 is something that we can do internally as a company by looking at the possibility of replacing our natural gas fuel with the green hydrogen. And then the second objective is to understand the opportunity, how is the behavior of iron making and integrated steel making options for future development. So this study will encompass our near-term strategy, which is on the scope 1, as well as our longer term in terms of how GRP will look into the new technology of steel manufacturing. So looking at our emission 74% as scope 2, the green power sourcing also one of our focus as of now. We will try to work in this case in Indonesia context. I think PLN is the majority source of power. So we need to have that discussion with them as well in terms of how GRP could do more to reduce the scope 2 emission basically. And I think what I can share as well is that as a company that currently exploring green hydrogen, and I think Pa from Pupuk just now shared the same challenges or aspects to be considered. We're looking at several points here, which is the safety aspect. We know how hydrogen characteristic and then in terms of safety also needs to be considered. And then how is the availability of renewable energy basically to support the electrolyzer, right, in order to achieve the green hydrogen. And then we're also looking at how the impact to the decarbonization itself in the means that how our carbon profile will look like considering the project capex as well, right? Because I think as a private player, again, in terms of sustainability topics, we have to ensure profitability as well and finding the right balance, basically. So we have to find that balance in terms of decarbonize as well as financing aspect. Including the impact to our production costs, of course, we're currently studying also on the hydrogen costs and how does that impact to our cost of manufacturing, of course. And again, last point, because majority of the study will still focus on the equipment and burner of those technology, but we have to also pay attention on how do we store and transport the hydrogen later in order to optimize the usage of green hydrogen in our plant. So I think with that in mind, this is my summary and key takeaways from us as a steel industry player. Understanding decarbonizing steel industry required massive effort and investment because we are one of the hard to abate industry. Decarbonizing our entire value chain means required massive effort and ecosystem to support. Second is that strategic business and environmental benefits, like I mentioned, finding the right balance, understanding the environmental regulation, leveraging the green hydrogen, as well as providing an opportunity for business to meet the corporate sustainability goals. Third, the clean energy transition, where we see green hydrogen will serve as a clean and sustainable alternative to traditional carbon-intensive inputs in steel manufacturing, which is with the aim to reduce the carbon emission. And strategic partnership, which I touched base before, collaboration with the right player right industry technology providers is also one of the key important aspect that we have to pay attention to on this journey. So with that in mind, that's from my side. Thank you for this opportunity. I'll hand it back over to Pak Rico. Thank you.
Thank you, Ms. Shirin, for your very interesting presentation. And now I'm gonna go straight to the questions and comments that come from the audiences. If there's any question or comment, please submit it to the in the Q&A tab, ladies and gentlemen. Okay, there is one question from Pak Ridlo. I think this question is addressed to Ms. Shirin. The question is, the steel industry is among the commodities targeted under CBAM. What strategies have been implemented by Gunung Raja to reduce emissions in steel products? Please, Ms. Shirin.
Yes. Thank you, Pak Ridlo, for the question. Yes, we are fully aware on this CBAM. So we as a company, what we do is that our understanding to the CBAM is that the first 2 years they will focus on the data transparency. So we are preparing ourselves in terms of data collection, where one of it, what we have done is we are certifying our products to the environmental product declaration, where this is one of the certification which required us as the company to measure each product, how the carbon footprint look like. So with that initiative that we've been doing, we believe that can support us in terms of having us prepared to the CBAM mechanism for the first 2 years of implementation. We're also working closely with Ministry of Trade in this case on how we anticipate the CBAM. We are still in that preliminary discussion to understand how will this Indonesia government looking at the CBAM. So in a way, we have to find the right regulation, right, as a domestic player from Indonesia, and how we work that with government, basically. Thank you, Pak Rico.
Thank you. Thank you, Ms. Shirin. Okay. Let me check. Okay, I think I took the liberty to ask questions to Pak Traino and Gunther. My first question is to Pak Traino. As Pupuk Indonesia is Indonesia's largest fertilizer producer, what do you see, Pak Traino? Will the products of Pupuk Indonesia, the fertilizers, the increase of price if you use green ammonia or green hydrogen, and how much is the increase of the final products to the customer, and how Pupuk Indonesia overcome that issue? Maybe that questions for Pak Traino. Maybe I will ask straightly to Gunther. My question is, how do you see the competitiveness, Gunther, of SAF, sustainable aviation fuels, compared to traditional fossil fuels for developing countries in Indonesia? Is there any cases in other countries as well that can be used as a reference? Maybe from Pak Traino first. Oh, okay, Pak Traino, still with us, Pak Traino? So maybe Gunther first, please, Gunther.
Yes, yeah, thanks for your question. So of course, the SAFs will be more expensive than fossil fuels in a long view. So it will cost more money. The point is, starting from regions like Europe or also the US, the demand will come for these kind of products. So it will be consumed, and the price has to be paid in Europe first. And then countries like Indonesia can, of course, benefit from it by, in a first step, producing it due to the availability of biomass. Indonesia would be a country ready for this BTL route, and then really bring it to Germany, for instance, or to Europe. And then, of course, by development of the technology, it will get cheaper and cheaper. And I think also perhaps in Indonesia, the regulations will come at a certain time where it's also somehow mandatory to blend in sustainable aviation fuels. So I see it in the long term, of course. So we need it worldwide. So in the long term, of course, in Indonesia, SAFs will have also a market. But I think the first step will be produce it in Indonesia, bring it to Germany, and then earn money with that. And the second step, I think it's also possible to use it in Indonesia as well in a broader range.
Yeah. Thank you. Okay, I think I see another question from from Pak Cahyo to Meshirin. Will there be any selling price increase, Meshirin, from Gunung Raja products if you incorporate hydrogen? And how do you see or overcome that issue? Please.
Yes. Thank you, Pak Cahyo. So this is also one of the big question, Pak Cahyo. I think for now we cannot sort of like share with you directly in terms of selling price increase or premium in this case, because we're currently focusing on formulating those cost impact basically. And we are also aware that we as a commodity will also sort of like need to be competitive. So how does the management now looking at that is that we need to, again, emphasizing finding the right balance. We need to understand how the cost will impact us, the hydrogen cost, and then we'll take it from there to assess the competitiveness basically to be applicable to our products.
Right. Right. Any more questions from the floor? Okay. Let me check. All right. I think we have come to the end of the session. Thank you, Meshirin. Thank you, Gunther and Pak Traino for joining us in this session. And with that, I think we come to the end of this online seminar. Before we close this seminar, I would like to wrap up this event today. I'm going to read some small points that we already have heard from all speakers today. We have Mr. Tim Nees from GIZ Thailand. He explained that he's ready. GIZ is ready to facilitate hydrogen developments, partnerships, and initiatives in Indonesia. We also have Mr. Beni Purwanto from the Ministry of Industry that told us that the ministry is fully supports the development of hydrogen, especially the industries that develop the equipments and tools for the hydrogen. And the ministry also has mapped out hydrogen use for various sectors, such as automotives, power plants, and other industries. We also have Mr. Stefan Duch that explained to us the market of hydrogen globally and in Europe, and how Hydrogen Global Foundation could help Indonesian to reach the international market. We also have Mr. Nick Stansos from TÜV Rheinland, provides us wide ranges, tells us wide ranges of hydrogen certification, including green hydrogen and low carbon hydrogen. Joining with us also Mr. Ricky Cahya from PT PLN Persero. PLN right now is on the expanding drive for hydrogen production, and PLN has been officiating its first hydrogen production and is looking forward to expand even greater. And we have Mr. Traino from Pupuk Indonesia telling us that Pupuk Indonesia plans to produce green ammonia. In the first phase, it will produce 86.6 million tons per day of green hydrogen. And joining with us also Mr. Gunther, telling us that providing solutions in biomass to liquid for sustainable aviation fuels, and Mrs. Shirin Omega from Gunung Rajapaksi explaining the company's ESG roadmaps and decarbonization plans in the company. So, ladies and gentlemen, thank you so much for joining this event today. We humbly ask you to fill up Before leave, we humbly ask you to fill up the feedback form before you leave. The link will be attached in the chat box in this application. So finally, on behalf of ECONIT and GIZ, I sincerely thanks to all speakers and participants that joined today's online seminar. See you again and have a great evening.